Okay, good afternoon, everyone. Before starting our lesson, we have already completed mm, the introduction part of our course databases. So I'll randomly choose some of you and will ask some few questions. Okay. Okay. So uh, enrollment number 3, Atul Sharma. Are you there? Okay. Enrollment number 14, Helen. Can you hear me, people? My students, am I audible?
Yes,
Yes,
ma'am.
ma'am.
Okay. So, Atul Helemba. Okay, no one is here. Abhijit Anand, enrollment number 1.
Yes, ma'am. Present, ma'am.
Okay, so Abhijit, tell me what is a metadata?
Yes, ma'am.
What is a metadata?
Metadata.
Hmm.
Sorry, ma'am. I can't recall this.
Uh, so in this slide, yeah, this one, data dictionary. Data dictionary, the other name is metadata. So that is what I'm asking. Okay. Tell me what is this data dictionary?
Ma'am, data dictionary.
Hmm.
Like we can say it, ma'am. I think it's related to set of information like content, format, or structure of database. Like
Hmm.
relationship between its element. Like here we have the relations in the form of the uh, like a table or something we can say.
Hmm.
It's related to usually related to relationship between various elements in the database. Like it's used to control the database or maintenance of the database.
Hmm. So partly you're correct, but not means it is not just the relationship between the data. It is going to store each and every information about the data, okay, data that we have in our database.
Yes,
So that
it's
data
you.
about data,
Yes,
you can remember it as data about data.
yes, ma'am. Set of
Okay,
information like it contains the in the for it,
set
like
of
it's
information like data type, relationship, and all those things, all of them. Okay.
uh, yes.
Okay, then enrollment number 18, Abhishek. Abhishek, are you there? Enrollment number 27, Manjit. Manjit. Enrollment number 24, Nisita.
Present, ma'am.
Okay, Nisita.
Yes, ma'am.
Uh, Nisita, tell me what is a transaction?
Transaction.
Do you remember?
I don't remember.
Okay. Do you know what is a data redundancy? Okay, Nisita.
Hello, ma'am.
Yeah, Manjit. Manjit.
Yes, ma'am. Present.
Okay, tell me, Manjit, do you know transaction? What is a transaction?
Ma'am, I know only it's regarding money, I think.
Yeah, so if you that is also a transaction, bank related transaction, but I'm talking about database management systems transaction. Even the bank related transaction, the name is given to that particular transaction because of database management system. But you can say the bank related transaction is also the database management system transaction. But when we say what is a transaction in database management system, you can't answer like it is the bank transaction, means money transaction from one account to another. Okay.
Okay.
So in the point in the database management system point of view, what is this transaction? Can you explain me with the example you are saying, the bank transaction?
Ma'am, I think retrieving data from database or adding data into database.
Okay, I'll tell you again. Transaction consists of set of instructions. Okay, it consists of set of instructions uh, if you are going to uh, the same example that you are saying, I'll use that. If it is a bank transaction, then if say for example we are going to send some money from one account to another account, then what happened is I have to deduct the amount from the first account and I have to add it to the second account, isn't it? So it consists of many instructions. Many instructions are executing while performing this particular transaction, isn't it? So a transaction consists of many instructions, but these instructions have to be performed as a whole. It has to be we have to think it as a single instruction. Okay, it has to be executed as a single instruction. That means if it is to be executed, then all the instructions should be executed, and if it is not executed, then all of them should not be executed. Okay, because if some part of the instruction is executed and some of them is not executed, which belongs to the same transaction, then data inconsistency will be there. Do you get what I'm saying?
Yes, ma'am.
Okay, so this kind of set of instructions related to our databases, which should be performed as a whole, or which if it is not executed, then all of them should not be executed, means it has to be considered as a unit uh, of a unit instruction. Okay, so this kind of set of instruction is known as transaction, a single transaction. So when we say a transaction, always remember that it consists of set of instructions, but it is treated as a single instruction. Okay. Okay, then let us start our lesson. Today's lesson will start ER model. So I have briefly introduced the ER model in the previous class. So ER model in long term, the name is entity relationship model. So from the name itself, we know that this ER model is a representation. We already know that it is a representation of our database, isn't it? So this particular model, we will be able to use it in order to represent conceptually our database. Okay. So from the name itself, it is known as entity relationship model. That means in the representation, we are going to represent entities and the relationship between the entities. Okay, so what is this entity? So this entity is a real life object. Okay, it can be anything. It is a distinguishable item of that particular database. Okay, so for example, in this example here, I have shown a very simple ER diagram of a library management system. Okay, in a library management system, you can identify many entities, but here I am identifying only two entities. The first one is book, and the another one is user. Okay, there are two in order to explain what ER model is. Okay, in library management system is also a very huge uh, database management system. So it might contain many entities, but here I'm just taking two of the most important entity, and that is book and user. Okay, and in ER representation, the entities are represented by rectangles. So that is why book is represented by a rectangle and user is also represented by a rectangle. Okay, so these are the entities. So for a database, if we are going to represent it by using a ER model, then we have, for that particular database, we have to identify the entities. And these entities will be represented by the rectangles. Okay. After having the entities, we have the relationship between the entities. Okay. So how this relationship, how we are going to identify this relationship? So here, a particular book and a particular user is related to each other only when the user borrowed the book, isn't it? There won't be any relationship if a user is not borrowing any book or a book is not borrowed by any user. Okay, so the relationship is created only when a particular book, say for example the database system concept, is borrowed by a student XYZ. Okay, so the relationship between that particular book and that particular user is created when the user borrowed the book. So here I am representing a relationship type borrowed by here, and it is between the entity type book and entity type user. Okay, and the relationship type is represented by the diamond. Okay, it is represented by diamond. So I have already we already see how the entities are represented in a ER model and how relationships are represented in ER model, and they are connected by the by these lines. Means there is a link between in books and user by using this relationship, and it is represented by the lines and the relationship type that is represented by the uh, diamond. Okay. And what about this ovals? These ovals, they are the attributes. Okay, they are the attributes. Attributes. So entity types can have attributes, and then again, and relationship type can also have attributes. So the attributes are represented by the ovals. Okay, and it describes the characteristic of the entity or the relationship type. So here, book can have means a book can be means it can be described by the title of the book, accession number of the book, author of the book, publisher of the book. Okay, so these things which can be used to describe the book, they will be represented by the attributes, and in ER model attributes are represented by ovals connected to the entity type. So if it is connected to the entity type, then it means this attributes belongs to the entity type book. Okay, same thing here also in users can be described by user name, user address, user status, code, card number, like this. Okay, again, relationship type can also have attributes. Date of issue here, the relationship type borrowed by is having a single attribute, and it is date of issue. Okay, so this is a very simple example of entity relationship model, entity relationship diagram, where this diagram is representing a library management system. It has two entities. The entities have its own attributes, and the entities are related to each other by using the relationship type borrowed by. Okay, and borrowed by also have its own attributes. Okay. Now let us define all the terms that we are going to use here in entity relationship model. So the first one is entity and entity type or set. So I'm using these terms in the previous slide. So I'll just give the definitions. Entities, I have already mentioned it as the distinguishable item of a database. Okay, entities are going to be the real life object. A student, a particular institute, a person, faculty, staff, anything, a car, anything, any object, whether it is a physically available object or conceptually available object, anything, it can be represented by the entities, by the entity. Okay. And what about entity type or set? So entity set or entity type is a collection of entities which is sharing the same type. Okay. So for example, here I am saying that the entities are represented by this particular rectangle. But actually what is happening is the rectangles are representing the entity set or entity type. Okay, means all the books belongs to this particular entity type or entity set book. Okay, so when I say an individual book, say database system concept, it is an entity. Database system concept is an entity, a single entity. Okay, and that single entity belongs to this entity type book, entity type or entity set book. Okay, so now you know what is entity and what is entity type or set. Entity is a particular item, and entity type or set is a set of entities which belongs to the same type, which has the same type. Okay. Now, what about attributes? Attributes of an entity or a relationship type, anything. The attributes of a particular entity, say for example, database system concept again, and it can have the name of the book. Database system concept is going to be the name of the book, isn't it? And the author of the book, authors, it will have the author, SSN number of the book, and the publisher of the book, isn't it? So this attributes, we already know it describes the entity. Even if it is a attribute, the attribute is a attribute of a relationship type, then it is going to be the things which will describe the relationship type. Okay, same again, relationship and a relationship type. When I say a relationship, then it is a single instance of a relationship. Okay, a single association means it is an association or mapping between two or more entities. When I say a relationship, then it is a mapping between two or more entities. Okay. When I say a relationship type or a set, then it is a collection of relationship of the same type. Okay. This is same as this entity and entity type. A single entity, a single relationship which will be represented by, means we have to use the term relationship for that. And if it is a collection of those those relationships, then it has to be, we have to use the term relationship type or set. Okay. So for example, when XYZ borrowed database system concept, then the relationship between this database system concept and the user XYZ is a single relationship. Okay, it has to be represented by a relationship. But if if we have to represent it in a relationship in an ER model, then this borrowed by it is used to represent a set of such relationship type. Okay. So these are entities, attributes, and the relationship type. Other things that we need to know is about attributes. Let us see what we need to know. Composite versus simple attribute. Here, what is simple attribute? I will tell you. Before that, I will just explain what is composite attribute. So composite attribute, if attribute can be divided into subparts. Okay, if an attribute can be divided into subparts, then it is known as composite attribute. I'll give an example. Name of a person. Okay, name of a student. if there is an entity called student and the name of the student is a composite attribute. Why? Because it can be subdivided into first name, middle name, last name. Okay. If an attribute can be divided into smaller subparts, then it is known as composite attribute. If an attribute cannot be divided, then it is a simple attribute. Okay. Any example of simple attribute? Anyone?
Gender, ma'am.
Yeah, gender. Gender is a simple attribute because we can't divide it into subparts. Okay, good. Okay, now let us see the next one, multi-valued attributes and single valued attributes. So multi-valued attributes, if a particular attribute can have multiple values, then it is a multi-valued attribute. Okay, and if it has only a single value, then means if a attribute can have only a single value, then it is a single valued attribute. Multi-valued attribute, again, your address of a person. So address of a, say if it is a person working in an office, then it can he or she can have a home address, office address, means work address of his or her workplace. And then again, if he or she is living in a quarter, then temporary address or the address of where he or she is living right now. Okay, so address means address of a person can be multi-value, isn't it? If you people are staying in the hostel, then you can give the address of your hostel as your address again, isn't it? So like that, if an attribute can have multi-valued, then they are known as multi-valued. They are categorized as multi-valued attributes. And attributes which cannot have multi-value, they are single-valued attributes. Again, another example is these days, phone numbers. Mobile phone number of a person can means it can be a multi-valued attribute, isn't it? One person these days, because of the technology, we can put multiple SIMs in a particular device, and we can be using two or more two numbers in a uh, by using a single device, isn't it? So those are multi-valued attributes. What about this stored versus the derived attribute? So derived attribute and stored attribute, again, I'll use an example in order to explain it. Birth date. Birth date. If there is two attributes, one is birth date and one is age of the person. Birth date of the person and age of the person. Then from the birth date, we can calculate, we can derive the age, isn't it? So derived attribute and stored attribute. Stored birth date is going to be the stored attribute, and age is going to be the derived attribute. Okay, so it is based on two, means always, I mean, if we have a stored attribute, then and there should be a derived attribute which can be derived from the stored attribute. Okay, so this always comes together. Complex attribute. So complex attribute, again, complex attribute is an attribute which is composite and at the same time which is also a multi-valued. Okay, which is a composite, means which can be divided into subparts and which can have multiple values. So those attributes are known as complex attribute. I'll use the address attribute again. Address can be subdivided into many parts, isn't it? Like street, name of the street, number of his home number, and then the PIN number, all those things, it can be subdivided into subparts, isn't it? Address can be divided into subparts, and the city where the address belongs to. Okay, so it can be subdivided into it can be divided into subparts, and also address can have multiple values. So such kind of attribute is a complex attribute. Okay, same thing, the name attribute that I was saying as a composite attribute can also be a complex attribute. Why? Because a person can have multiple names. He or she can have a pet name. He or she can have a formal, means the official name, isn't it? So those are complex attributes. Okay. Now key attributes of an entity type. So key attribute is used to uniquely identify entities in an entity type. Okay, so uniquely identify the entities in an entity type. So if we have a student entity type, then the key attribute for the student entity type is going to be enrollment number, isn't it? So each and every means for each and every person, the enrollment number is going to be unique. That means when the enrollment number is given, uh, it can be means it can uniquely identify the person, the particular student, isn't it? So attributes, key attributes is going to be a single attribute, or it can be a set of attributes which can uniquely identify the entities belonging to the entity type. Okay, so these are some of the things that you need to know about attributes. Any doubt here? Key attributes can be made up of more than one attributes also. Okay, it can be made up of a single attribute, or it can be made up of more than one attribute. Okay, so this is all about attributes. Relationship type, set, and instances. This we have already, means I have already defined it in the previous slides, but here I'm giving an example here, means using the book, user, and borrowed by. So when we say a relationship instance, then what is this? This is an association between the entities. This we already know, where the association includes exactly one entity from the participating entity types. Okay, so this association, say for example, this relationship instance R1, R1, R2, R3, R4, they are the relationship instance. So by using this relationship, if the whole relationship set is met, isn't it? Means the collection of this relationship instances is the whole thing, that is the relationship set borrowed by. Okay, so this each relationship here, each relationship is the association of the entity types where a single entity is associated from each participating entity type. Okay, here this in this borrowed by two entity types are participating. One is book and one is user. Here this R1 is a relationship instance where B2 is participating and U1 is participating. So this kind of things, a single relationship is known as relationship instance. Okay. I will again tell you what is this association of entities, where the association includes exactly one entity from each participating entity type. That is the relationship instance. So this relationship instance, the collection of relationship instance map this particular relationship type borrowed by. Okay, and and here you can see, here a particular book, means a particular book can participate only in one relationship instance, but from here, from this side, user can borrow more than one book, isn't it? So it is means a particular user U3 is associated in two relationship instance R3 and R4. Okay, so by this, just remember this particular concept, and I'll tell you the name that is given to these relationships. So about relationship, what you need to know is, the first one is relationship degree. So what is the relationship degree? It is the number of participating entity type. Okay, so here I'm just showing a binary relationship type. This is a binary relationship type because the degree of the relationship type borrowed by is 2. Okay, because it is participated by only two entity type. One is book and another one is user. So this is a binary relationship type. We can also have relationship type which is having more than two, means which is having more than two participating entity types. Okay, three or four may be participating in a particular, in a single relationship type. So those, according to those numbers of participating entity type, we will give the degree of the relationship. Okay, so the number of participating entity types is the gives the degree of the relationship. The second one is recursive relationship. So what is a recursive relationship? The entity type participates more than once in a relationship type in different roles. Okay, such type of relationship type is known as recursive relationship type. I'll give an example. If we have institution management system, then what will happen is for a department, if we are for a particular department, if we are having an entity type faculty, okay, a faculty, then what will happen means from the faculty there is going to be a person who will be acting as an HOD, that is the head of department. Okay, and the head of department is monitoring the other faculties, monitoring, you can say monitoring or organizing the department or anything. So he or she is taking a responsibility in order to monitor the other faculties, isn't it? So this monitorship means this particular monitor is going to be a relationship type between the HOD and the other remaining faculties. And the HOD also belongs to the faculty, the entity type faculty. We can't have another entity type for faculty, for HOD, for the single HOD, for a single person in that department database, isn't it? So the HOD also belongs to the faculty entity type. So that means the relationship monitor is participated by an entity type more than once, means twice times, using different roles, isn't it? So such type of relationship is known as recursive relationship. So same entity type participating more than once in a relationship type in different roles, they are recursive relationship. Okay, if we have a recursive relationship, we need to give the role name. Okay, we need to give the role name from each participating entity types. Okay, say in the example that I'm giving you, one is ISOD and the remaining faculties are that's the normal faculties, isn't it? So we need to give this role names if we have a recursive relationship. So that's why this role name and the recursive relationship comes together. Okay. The fourth one is cardinality ratio. So in the formal way, it is defined as the maximum number of relationship instances an entity can participate in. Okay, maximum number of relationship instances that an entity can participate in. I'll give this example in order to explain what is cardinality ratio. So there are there are four types of cardinality ratio. One is 1:1, another one is 1:n, n:1, and m:n. These are the general cardinality ratio that we have. So here, this borrowed by relationship type, what will be the cardinality ratio for this borrowed by? Okay, it is going to be from the book side, it is going to be 1, and from the user side, it is going to be n. Oh, sorry. From this side, it is going to be n, and from user side, it is going to be 1. Okay, that means a user can borrow many books. Okay, many books. There is limitation for a library management system. A user can borrow 5 books or a user can borrow 6 books. But we can say one is here we can say 5:1 or 6:1, but in general way, in formal way, if we have to define it, the cardinality ratio for this borrowed by, it should be n:1. Okay, that means one user can borrow many books, but from this side, one book can be borrowed by only a single user, isn't it? One book can be borrowed by only a single user. That is why from this side it is 1, and from this side it is going to be n. Okay, means user can borrow many books, so we are going to put n here, and a single book can be borrowed by a single user. It can't be borrowed by many users, isn't it? So that is why we are going to put a 1 here. So the cardinality ratio for this borrowed by is going to be n:1. Okay, you get it? Okay. What about the other thing, that is participation constant? Again, the formal definition for participation constant is minimum number of relationship instances. Minimum number of relationship instances that an entity can participate in. Okay, so you will be able to understand this cardinality ratio and participation constant when we have many examples of entity relationship diagram. But for now, the formal definition is just the minimum number of relationship instances that each entity can participate in. So there are two types of participation constant. One is total and another one is partial. One is total and another one is partial. For this relationship type borrowed by, what happened is from here also it is total, from here also it is total. Why? I'll tell you. If the user is a user of a library, then it means all of them is able to borrowed by, all of them is able to participate in this borrowed by. Okay, so that is why it is total. Again, if it is a book that is there in the library, then it should be able to borrowed by the user. So it is again total. If there is some restricted books, yeah, in normally in some libraries there are some restricted part where we put the books which can't be borrowed by the user. Then if there is some books which is belonging to this book entity type and which cannot participate in borrowed by, then it means from this side, from this entity type, it is partial. Okay, from this entity type, it is partial participation, but from this user side, it is total participation. Okay, so that is participation constant. Cardinality ratio and participation constant. Okay, any doubt? Okay, then let us continue. We also have a weak entity type. So what is this weak entity type? If there is an entity type which depends on another entity type, means which does not have any key attribute, and it depends on another entity type, then they are known as weak entity type. Okay, so this one I will tell you with the example database that we are going to design in the next class, what which type of entity type is a weak entity type. But for now, just know that weak entity types are the entity type which cannot stay alone without the help of another entity type. Okay, so that is why their name is weak entity type. So weak entity type depends on another entity type. So if there is a weak entity type, then and the particular entity type to which it is depending, okay, they are known as identifying or owner entity type. Okay, and again, for a weak entity type, I have already told you that they doesn't have any key attribute. Okay, so if they don't have any key attribute, they are going to have a key, but still as they are the entity types, they need to have some key. Okay, and the key which is used for this type of entity type is known as partial key. They are not key attributes. They are just partial key. Okay. And if there is a weak entity type, then for sure I have already mentioned that it is going to depend on an owner entity type, isn't it? That means there is a relationship between the weak entity type and the owner entity type. Okay, and this relationship is known as identifying relationship type, because this relationship and the entity type, owner entity type, is used to identify the weak entity type. So that is why their name is identifying relationship type and identifying entity type. Okay, so these are all about weak entity type. Now let us see the representations. Notations, you will use rectangle to represent entity type. For weak entity type, will use double rectangle. Okay. For relationship type, we'll use diamond. For identifying relationship type, we'll use double diamond. Okay. And for attributes, we'll be using ovals. Key attribute will be the name in the name of the key attribute. We will underline the name of the key attribute in order to identify it as a key attribute, in order to represent it as a key attribute. Okay, there will be an underline here. Okay, and a partial key, it will be underlined by dotted lines. Okay, multi-valued attribute, double ovals will be used to represent multi-valued attributes. Composite attribute will be used, we have to, as it has subparts, it needs to have divided into subparts. So we'll be representing by using this one. And derived attribute, it will be represented by dotted ovals. Okay. And here, I'll just remove it, this one. So here, total participation, this one, total participation, and partial participation. How we are going to represent it means with the participation constant. How we are going to represent it is, if E1 is having total participation in R, then we will be representing it by double line. Okay, and if it is a partial participation, then we'll use a single line. Single line will be used to connect the R and E2. Okay, so total participation of E1 in R. So I'm just writing it here. And partial participation of E2 in R. Okay. And what about cardinality ratio? So it will be, the ratio will be written in above this line, which is joining the entity and the relationship. Okay, so this relationship is having 1:n cardinality ratio. So that is why I'm writing 1 here and n here. Okay, and instead of this representation, instead of this two representation, we can also use min max. Okay, min max. We can also use inside parentheses, we can use min max for the participation of a particular relationship. Mean will represent the this one ratio. Mean will represent the total participation, and cardinality ratio will be represented by the max. Okay, that means if this E1 here is having a total participation, isn't it? Total participation, and the cardinality ratio from E1 side is 1. So here in this line, if instead of this two representation, this line, we can have a parenthesis here, and in the mean we will write 1 because it is total participation, comma max, again it will be 1 because it is in the cardinality ratio we are having 1. Okay, and from this E2 side, inside the parenthesis, what will happen is, this is partial participation. Partial participation will be represented by 0. Okay, so in the parenthesis we will have 0 here, comma, and cardinality ratio is n, so we will have in the max n. Okay, so here it will be 1 1, and here it will be 0 n, 0 comma n. Okay. So all the things we will be using to design the database. So in the next class, we will see example databases, and then for those databases, we are going to use all these notations, all these symbols, and by using these symbols, we are going to design the database using ER model. Okay, any doubt? Am I audible to you all?
Yes, ma'am.
Yes, ma'am.
Okay, so any doubt? So you'll be able to design your own databases from the next class onwards. You are going to be a database designer. Okay. So if you have doubts, then means from the next class onwards, we'll start designing. Then it means if you miss anything, then you won't be understand. You won't be able to understand the later classes, because we will be using this ER model again and again in the later classes also for writing your queries, whether it is for writing your queries or whether it is for creating your database, your own databases in your lab classes. Okay, for your ER modeling also, we are going to use the same ER for relationship. Sorry, for relational modeling also, we are going to use the same ER models that we will be designing. Okay, that is why you need to understand. Today is 27. Abhijit Anand,
Present, ma'am.
Akash,
Present, ma'am.